So good afternoon, everyone. So my name is Isabel Ates. For those who don't know me, I found aird'eco drone, a survey company in 2015, to combine my job as a geologist in geophysics to my passion of flight, free flight and glider. I decided to specialize in archaeology, and now today archaeology is 50% of my work. The other half is with Surveyor, allowing me to look at different subjects such as quarries, construction, gas transportation, hydrology, waste storage, and more. My presentation today is a bit like a picture book, and I hope you will have some fun with it. So I will speak about the archaeologist needs, then speak about the equipment I use, and I choose 8 different case studies to illustrate the characteristics of these surveys, and I will conclude. So the goal of this UAV LiDAR prospection is to fulfill the need of the archaeologists, which are to obtain a macro topography map as accurate as possible, to look if some macro reliefs can correspond to artifacts, precise some morphological elements such as channel, geological features, and sometimes calculate a 3D model. Let's talk first about the equipment, the hardware. So my faithful carrier is an hexacopter built with DJI technology. Its main advantages is reliability, no vibration, and most of all, the equipment to get in all scenarios imposed by the French regulation. It has a parachute and weighs less than 8 kilos when loaded. And then I can fly in urban areas, which is very important, as you will see, for archaeology reasons, which the archaeology sites are often in town or near visitor centers. The autonomy of flight is between 15 and 20 minutes in this configuration. My sensor is the Surveyor. I won't present it to you. My current usual height of flight are ranging from 20 to 60 meters above ground. And I use a standard aird'eco antenna for post-treatment for prospecting area of 5 kilometers. Voilà. Let's lift off now. Connect the batteries, push the yellow button to start the recording, and off we go. Here you have the raw point cloud, see the trees, buildings. Here is a castle I will show you later. Here is a drone and its trajectory seen from above. We don't use so much the YellowScan live station during flight, unless we have to organize a demo flight for customer, but to replay the flight after landing and better explain what we're doing to our client. In order to control the number of point cloud we have and see if it's enough, we use the base station. This is the old version, I've understood, which calculates the LS file right away. Let's start with the first case. Here you are downtown Soissons, it's a town in the east of France. We were asked to prospect this wooded area with an arch, assumed to be a Gallo-Roman theater, one of the largest of the antique times, with a diameter of 144 meters. And we prospected also its environment, which is here. You will see it later. This case will allow me to go over all the follow-up of the process. So let's start with the field setup. We arrive at sunrise, install the aird'eco base station, check the drone, finalize the flight plans, and then fly. In this mission, it was a little special because we flew at 40-meter high on both sides of the facade of the ruined abbey. It's not a cathedral, it's an abbey. I flew only 5 to 10 meters apart from the facade, which is, the height is 80 meters high. So with the wind, it's sometimes a little tricky. Pond cloud visualization. Maxence, I know he's not here right now, made a nice animation in order to fly into the pond cloud. We were not supposed to model the buildings, but as we record 360 degrees, we found more aesthetic to include all the buildings. And even though we flew at 40 meters high, we can see, you're going to see, well above the spires of the abbey at 80 meters up. Then classification of the point cloud. Here is a theater part, and this is the southern part with the abbey. DTM extraction, and then DTM shading. Quickly, you see the circle of the theater, road embankments, and different features that archaeologists have interpreted. Normally, my job ends here. But in this particular case, no, sorry. We still have the 3D model, sorry. Alors, il se déclenche pas. Yeah. Where it's another visualization where you see well all the different features. So usually it's here where my job ends. But in this particular case, I thought, I think I may find something else in the orchestra of the theater, or I wish it very strongly. So I sought the help of a mathematician from the University of Brest. He was a visitor scholar of the Antiquity Department of Cambridge University, and he is also an archaeology addict. And he has a different view on the geophysical data. He processes himself radar and magnetic data. He tried on this site numerical treatment based on non-linear statistics. And here is the data, we just have it last week. And we can find some lineaments and some square angles. So this is not a DTM, it's another representation, it's non-linear. But we can find some figures in the orchestra, and the archaeologists think it's from medieval time. This is a football field with also lineament parallel and oblique to the football field pitch. We look at some old map drawings, and we see that where is the football field, where some French garden, and those lineaments might be relating to it. It's too new, and we didn't work much on it, but this exercise is really a great methodological interest. It opens up a field of research towards better interpretation or further interpretation of our data from LiDAR to fulfill the need of the archaeologists to discover things inside the data. It's not just to have an accurate topographic map, it's really to find features. So, now case 2. I will just say a few words because I presented to you 2 years ago in here in YellowScan days. So this is an oppidum, a 45 town of the Celtic age, of the Gallic age, where some Neolithic remains were found. It is barred with a 7 meters high rampart, and and it's covered with thick woods and boxwood, sometimes impenetrable. Classical topography may not be possible because it would have been too expensive. So you will recognize the workflow I flew with the Mapper 1 at this time. Point cloud, DTM, shading, 3D model, and we have printed the 3D model in resin. The main interpretation of the DTM was the localization of two entrances. You can picture it like this. The localization of base walls, so in different places. Localization of forgotten terraces. This is about 15 meters long. And this rectangle we can correlate to an old map of the 19th century, and archaeologists think it's much older feature. But I wanted to tell you a word about this case on the contribution of the 3D model. On one part of the rampart, one side of the rampart, there were a little wall on top covered by boxwood. The archaeologists wanted to have its geometry to understand the function of it. On the DTM, it was not very clear, but on the 3D model, it appeared very, very clearly. Then we were convinced the contribution of the 3D not only to serve the communication of the project, but also for the technical comprehension of it. The project follow-up is now 14 minutes YouTube video, speaking also about our research. And the field is now open to the public. And they install signs, including our work, to explain the site. Now, another oppidum in the east of France, called Attila's camp, because it is said that Attila was defeated there in the year 451 BC. Many archaeology excavations have been done here since Napoleon. It is exceptional because it is a circular double wall rampart of about 7-8 meters. And it was built in the 1st century in the place of the Gallic oppidum. And at this time it was a village with wood thatched houses with narrow lanes and grain storages. The data was collected in February, and the first thing that given by the archaeologists are on the point clouds on lineaments they found. And here the detail on the DTM of a motte féodale, which is a 45 45, this is the entrance, and this is blown ammunition during World War I. Case 4, to say very quickly, it's a castle who was once gardens, like a little Versailles. We were told to make the prospection of the wooden part. Fly the drone, point cloud. If we look at this particular wood area, then DTM shading, and here appear what we are looking so much is the pattern of the French garden with lanes and ponds that we could compare to an old engraving of the 18th century. And this is, and now the owner is currently printing the 3D model to help the visit of the blind person in his castle. Another castle of the north of France. Here is the wooden area. He wanted also to have the lanes inside his woods. So here it is, just to show you that the first result in Main were not a stroke of luck, but We can do it in other places. Show you the use of photogrammetry with the point cloud colorized with the autophoto. It's very nice to aesthetic and to localize when you have large areas with little landmarks, but don't forget that it's only superficial and the color doesn't mean nothing in depth. In south of France, the camp of Attila, sorry. The Battle of Orazio, where Caesar, not so often, was defeated there in October 105. 80,000 legionnaires and 40,000 soldiers were killed in battle here. It is covered with maquis, a thick Mediterranean vegetation, sometimes difficult to go through and scratchy. We had to walk all the way here in the bush to get to this place on the recent archaeological excavation and be able to fly, to take off safely. It was the only place we could take off. If we look a closer look at this part of the DTM, to say quickly, we have here a tumulus under study, but the DTM show different little tumulus around. We have those two zones, smooth elevation, which are related to buildings. We have the way of the rampart, and those two features might be related to it. And here a little anomaly that they will soon go worth checking on the field, in the field. Another place, another time, another battle. We are in the Dragon Cave. This is a crest here. The memorial is here, and it's built on top of forgotten choke quarries who have been used as barracks and front line between the German and the French. And the quarry exits on top of a 40-meter slope in each side. And to be noted here, it's a red zone. That is to say that mines have been never cleared there. It's forgotten to go there. Same process, point cloud, DTM, a 3D model. If you took a look at the north DTM, at first sight you don't see much. Until I was shown a picture of 1917 with trenches and bomb impacts. And then I looked my DTM with another eye, and archaeologists could name different trenches and path, railroad, etc. South part has a different signature, but since we can still name different features, what is very interesting here, remarkable, is this line here. It appeared to be a communication trench between the valley and the cave. I saw postcards of it, now it's filled with earth. And archaeologists, even though they knew it exists, cannot locate it on the field. You cannot see nothing. When it appears on the DTM, this micro-relief is called crypto-relief in our jargon. A quick word about UAV LiDAR and ground scanner. We were given the scan of an underground gallery under the Soissons Theatre, going from its periphery to the center. And we add it to our LiDAR point cloud, which is seen from underneath. And with this, we could have elements on the orientation of the gallery compared to the radius of the theater. In the same vein, we have a current project of a model whole area near Chartres on a remarkable section of Louis XIV Canal. It was designed by Vauban over 80 kilometers to bring water from the Eure Valley to feed the fountain of the Versailles Chateau. So I will not say much about it. I have some anecdote, but I have no time. So we are asked to prospect all this area. It's about 50 hectares. It is remarkable because it is where the canal starts its elevation on top of an embankment of 80 meters high, with excavation on the side. It goes over a valley with 2 siphons, which we don't know much about. And not far, there is a gallery, 160 meters gallery at the foot of the embankment, allowing a little stream to go under, to flow under. We start the terrestrial scan, the gallery, the siphon, here the orthophoto. So on the technical point of view, we want to model all the elements from above and underground to understand better how it worked together, or it have been working together, and to make Earth volume calculation. Our sponsor is also interested with the touristic side of it and has a project of recreational and educational walking paths all along the canal route. Conclusion. So we were able, with those prospection, to make topographic map from 5 to 20 centimeter accuracy, depending on the ground, on the vegetation, on a larger area, including the archaeological site. It is non-intrusive, and this is very important for archaeologists. Rapid, all the missions I show you require a day max of field and about a week of post-treatment. It is cost-effective for individual, association, public organization. It allows to give a sense to land movement that with no possible meaning on the ground. The soil keep the signs of the past, and we were able to increase the knowledge of known structure and to discover a new one. So we saw it's complementary to photogrammetry, ground scan, and even other airborne LiDAR. In the future, I think I will use different LiDAR sensors to adapt to different field problematic. And as we don't need only a topo map, but to find features in the data we record, I will use, I started, but I will use some other sensors like thermal, multispectral, and magnetic with my UAV. And I will look to further post-treatment to get more out of the data. Thank you for your attention.